In the continuation of introduction to DMCSEE, we will now take a look at operational products, mainly the drought monitoring bulletin and the maps that are available through the DMCSEE platform. All this information is available through DMCSEE web page, which you can see written here. Namely, it is www.dmcsee.org. And if you navigate to this web page, you have to look under the drought monitoring link here. And the drought bulletin for Southeast Europe is available as PDF file on the link that you will find on this page. Most of the material, most of the maps is prepared by using numerical weather prediction model in a special mode that I will describe a bit later, except of course the standardized precipitation index maps, which I explained already in the previous video. They are prepared using global precipitation climate center data. So about the maps that are prepared using a regional numerical weather prediction model. So it is a model, this is actually exactly the same model as most of the weather services use to forecast weather in the next few days. However, this model is used in a bit I would say adjusted mode for the drought monitoring. It is not nested into a forecasting global model. However, we use operational analysis, and we downscale this analysis in order to compare them to actually historical records. And historical records are prepared using so-called reanalysis. So this is a long time series of data from 1979, I think, when it starts. The most recent reanalysis system is ERA 5. And in that way, we are able to estimate anomalies, because of course drought is by definition a natural anomaly from a normal weather development within a certain time period. Of course, this time period should not be too short, because in a short time frame it is normal that weather has variations from extensive precipitation to more or less short dry periods. However, our experience teaches us that 60 days is a bit is quite optimal duration. So it's a bit on the short side, because only 1 month or anomalies that have time range in the order of magnitude a few weeks or 1 month are too short. There is too much fluctuations. However, with longer time periods, longer time ranges, there are already you can see anomalies that you can connect to a certain drought impacts. And of course, normally for the impacts mainly in agriculture, you use anomalies that are typically 3 to 4 months. So as I said, 2 months or 60 days are in a bit of faster side. So, but anyway, as I said, we have decided to use this time range, and then we provide results as a simple anomalies, as you can see here behind. So this is a simple subtraction of mean air temperature average through this 60-day period with respect to the 30 years of reanalysis data. So in this particular scale, you can see that you have actually anomalies in terms of degrees Celsius. In many times it appears that it is more illustrative or more instructive not to use absolute anomaly scale, but rather to show anomalies in terms of percentile classes. So here you have example of this same map. Well, it is a bit delayed for 1 week, but it is not shown in the absolute scale, but rather in percentile classes. So you can see normal, cold, and warm tercile, and top and bottom 5%, which are denoted as very cold or very warm. So this is again deviation of mean temperature. Of course, temperature is not directly connected to drought. It's much better to use so-called surface water balance. So under this term, we understand simple difference between accumulated precipitation and accumulation of reference evapotranspiration calculated through these models. And again, the same as described before, 60-day accumulation and anomalies calculated with respect to long, many decades of reanalysis data. So the time frame is similar as the one shown in the temperature case. So here behind you have anomaly of surface water balance in terms of millimeters, so in absolute scale. So you can already see here that are certain wet areas, but of course there are also certain areas that are very dry during first part of this year's autumn. And this is shown also very clearly also in the percentile map. So very similarly as in case of temperatures, so normal tercile, dry tercile, wet tercile, and dry and wet top 5% of the total distribution estimated from reanalysis data. So these are basically main tools that we use to prepare regional drought monitoring. Now, of course, remote sensing is also a very important part of drought monitoring, and you already had the whole module devoted to so-called land surface SAF, and of course we use also this data, but we had actually our experiences show that it is best to use certain points, certain pixels from these data sets, because it is very important that you have a homogeneous surface beneath this observation pixel. You need a large, well, for many countries in this region, it is the agriculture is very diverse, and the different cultures are cultivated in very small plots. So it is hard to have an area that is large and homogeneous. We had quite difficulties finding this kind of homogeneous surfaces, agricultural surfaces in Slovenia, and one example is here behind vineyards in the western part of the countries. And when we actually allocated these coordinates of this homogeneous surface, then we plot simple time series of these certain remote sensing indicators. In fact, our preference is to use fraction of vegetation cover, or FVC, but it is very similar if you use also FAPAR or maybe leaf area index or similar indicators that I'm sure you are already familiar after attending the module that is covering this stuff. And sometimes, so you can see here this time series data is plotted for different years, and 2013, so this dark yellow line is corresponds to the year with quite severe drought in Slovenia, and you can see quite clearly the anomaly of vegetation response here, which is below this black line, and the black line is reference, so the average time evolution of vegetation on this specific point through many different years. And this can be quite a good indicator for drought development. So I will now go briefly through the drought monitoring bulletin. So as I mentioned, it is available as a PDF file through the web page. First, at the beginning of this document, you have so-called hotspot. You can see it here in this yellow rectangle, but it is intended mainly for those who do not wish to read through the whole document. It is very short summary of what is the most specific attribute of this current situation. Then in the continuation you have maps. So here you can see average temperature, so very similar maps as you have seen in my previous slides. Then you have remote sensing products, so the same as I showed you for the case of Slovenia. We have during the collaboration with experts from different countries of the Southeast Europe, we have established many of points of coordinates with homogeneous agricultural cultivation practices. So we have some metadata, so some information on what to expect on these locations, and you have time series of this fraction of vegetation cover plotted through for each of these locations. But on the end, of course, there is also a map available for the whole region. And what is very important, as you might recall from the description from the previous video, from description of the project, it is planned to it is important to track also the impact reports. So we have currently my colleagues who are preparing the drought bulletin are scanning actually online media that are available also to us, and that are mainly research, of course, for those that are available in English language. So we can scan, we see if there are any records of impacts that are connected to the maybe spots that are indicated through the drought monitoring system that might be problematic. So again, the final message of this second part of the presentation is quite similar to the first part. It is very important to try to establish connections between drought monitoring data and impacts that are actually started to show on the ground. And finally, maybe I can just give you some information about our plans. So the plan is, of course, to mitigate this PDF bulletin completely to the DroughtWatch platform. DroughtWatch is a system that you will be more familiar with after the session that is dedicated actually to this platform, and then you will understand how it works and how this whole bulletin can fit inside. Okay, so this finalizes the second part of the DMCSEE introduction.